What we got here is that modified intake that we were working on a while back. Might as well make this Jeep the lucky donor to receive it. So I just kind of pressed for a little bit of time to kind of get this thing done, functional, and so we can use it. And you can see that we've got some different color material in there. And what this is it's like a JB Weld epoxy, two-part epoxy that you mix it up and then put it in there, it hardens up, and then I'm using the rotary tool to grind down some spots and smooth it out and stuff like that. This is what we've ended up with, and what I did was I tried to eliminate as much space as possible in this intake. What I'd done before was I basically filled in this area here on the top and in between the two runners, and then I felt that this was a dead space and this was a dead space here. So what I did was I just kept plugging more material in there, and then down in here there's like a void space down in there, so I just used my leftover material and I threw it in there to kind of smooth it in. So then now the dead space, we've eliminated that as well. I made a couple templates here that are the same in an attempt to try and make them as close to possible on both sides. Basically the template kind of went in like that, and then that gave me an idea of where I had to put the product in to match that shape. We also gasket matched all the intake runners here while we're at it, and then you'll see there's a little bit of a groove here, might be hard to tell. What I did was I milled this down to compensate for this ridge here. Of course, you want to dry fit everything first before you remove it off the mill. Make sure that everything fits on there before you remove it, so you don't have to set everything back up again. And also too, we have to measure our depth of the hole. And we had a viewer make a comment a while back, and he said the reason why these things leak is because the bolts are too long. And I checked, and he's right. Maybe not all of them, but some of them, and the one that I checked, the bolts were just a little bit too long, and so that's going to compromise your squish and your torque to get that plate on the top there. Now that I've milled this down, I have to measure that and make sure that I have the right size bolts. So that's going to be about 3/4 inch depth in the hole there. And what I got here is about a 5/8 on that bolt there. And then what I'm going to do is I will use some blue Loctite when I torque this on. I do believe that's going to be 8 foot-pounds for 1/4 inch bolts. And then we're going to use the black silicone here because it's the maximum oil resistance silicone. What we'll do is we're going to run our bead in here, but then we also want to run a bead on those edges as well to seal that, because we want this to be sealed as well. The torque value I used was 8 foot-pounds, and multiply that by 12, should be about 96 inch-pounds. And then when I torqued that down, it went 50 inch-pounds. After I'd let it sit for about half hour, let that RTV sealant tack up real good, semi-solid kind of deal. And then I torqued it down to the 50 inch-pounds, and then I left it. I left it for, more than 24 hours, so it's set up completely. And then that is when I go back and I torque it down to the 96 inch-pounds. I'm just scraping off the leftover material here. Using a Olfa blade here, I'm gonna scrape that off, rub that off, make sure none of that stuff ends up in the engine. And then we're going to transfer all of our parts off of this intake manifold and put it on this one for installation. We've transferred all the components onto the intake manifold here, and I thought since we're going to be using the modified intake, we might as well use the modified throttle body as well. And this is something that we worked on a while back, and you can see here a couple of things that we did. We filled in this void space, so this is on this one here, and here's that void space on the original one. We also cut down these walls here that protrude up above this surface. And you can see over on this one here, you can see where we've removed all those. And then we've made this portion flat here. Notice that we've got this hole. It serves two purposes. It holds our hold down rod here that we've made. And we try to thin that out as much as possible to reduce any turbulence and airflow in the center. And then in the middle, if we take a look, might be hard to see there, but there's a hole. If we get a better look here at that hole goes all the way down and it is incorporated with this here, which is going to be our idle control sensor here. So there's a little plunger in this, and that's going to open and close in the chamber in there to let more or less air in for our idle, because the throttle is closed, so the air is going to be coming in through that hole, as big as you need for that to function. And if we find it's not, then we just make that hole larger. When we take a look in this valley here, it is on the end, and that's what the plunger is going up against to do that. As you can see, this is where our hole is. So the plunger still serves the same purpose as it does here, but it goes into that hole that we've drilled through. And then if we take a look here, that threaded rod mechanism, that's just a gaudy piece that can't be good for airflow of trying to go by that thing. So that's why we built this kind of slender rod piece here. It's got to be an improvement over what we got going on for factory there. Now if we're going to torque things down, this ends up being 5/16, that should be 17 foot-pounds, or if you want to go 204 inch-pounds. That's what I'm doing. I don't torque that, just hand tight. Again, these here don't need to be torqued, just hand tight. Those are 15/16 again, so if you want to torque them down, 17 foot-pounds, 204 inch-pounds. So we've installed all of our fuel injectors on both sides here. We've installed our intake sensor here that just threads in. This is brass. Clean the threads up. That's self-sealing. You don't need any sealant to go on there. Just tighten that in by hand. Again, brass plug here. Don't need any sealant. Tighten that in by hand. We've got our temperature sensor right there. Same thing. Brass. Clean up the threads. Tighten it in by hand. We've got this thing here, and what I've done is I've glued the gasket to the neck, so then when you pull that off, if you're working on the vehicle, the gasket stays with the removable piece, so then it's easier to clean and maintain outside the vehicle rather than having it glued on top and then you're bent over trying to scrape and clean that in the engine bay. We've switched over our hose here. Our clamps are loose. Once we get that positioned where we want it, we'll put these clamps on where we need to tighten this up. This here has to be put on a certain way because there is the bracketry that goes over top of this, so this is going to have to go on a certain way to fit properly. What we got going on here was another modification that I had made, the idea being this is the top rad hose here. So what we want to do is we want to go above the highest point in the cooling system to remove all the air when we bleed the system as we charge it up. And when I'm doing that, I'm going to have the vehicle running. I put a pipe nipple in here that comes up above our highest point, and then I'll open up my valve here and I'll let the air release out of the highest point. That's the idea behind this piece here. So in this case here, we've cleaned the surfaces really well, and ordinarily you want to have the gasket on the removable piece so it's easier to deal with outside the vehicle, but in this case we have to kind of put it on the heads and the intake manifold because we need to put that RTV sealant in the corners there. Also too, there's going to be some tabs on the end of the gaskets here, and you'll just trim those tabs in order to line up all of your holes on the head. In some cases you cut them off entirely, and in other cases you might just trim them shorter. But what we've got here is we've laid the gasket in place to line up all of our holes. We have our RTV sealant in the corners, and what we'll do now is we're going to set our head on there, and then we'll just let this thing chill out for a little while before we attempt torquing anything down, because we want that silicone to kind of tack up. So we've got that intake set on there. We're just going to leave that sit there. We've got some bolts holding it lined up in place. We'll go have something to eat, come back, and then by that time should be ready to start torquing it down. One thing that might happen while you're putting this intake manifold on and lining up this hose and installing it, your front gasket may shift in there, so you might have to adjust that after the fact. Once you get this hose hooked up, take a look, see the state of your gasket there, and you might have to adjust that a little bit. We're throwing on the tappet covers now, and we've got these rubber gaskets here on both sides. It doesn't matter what side you put them on, they're basically the same on both sides. Throw those down, they go on dry, and then for the 1/4-inch bolts, that should be 8 foot-pounds or 96 inch-pounds to tighten those down. And because I think there's a metal inside here with the raised rubber, I think you could go all the way without any worries on that for full torque spec. Another thing we want to remember too is this is a good time to bolt up our ground straps for either side. There's one strap that goes to each cylinder head, and that's going to be a 3/8 in the back there, and so that's a 9/16 wrench, and that's just hand tight.